This is another sign of the times, an analysis, and a commentary. In the beginning, ripples from the Big Bang. When scientists jubilantly announced that a telescope at the South Pole had detected ripples in space from the very beginning of time, the reverberations went far beyond the potential validation of astronomers' most cherished model of the Big Bang. It was the second time in less than 2 years that ideas thought to be radical just decades ago had been confirmed. At least, so the optimists think, by experiment. The first was the discovery of the Higgs boson, associated with an energy field that gives mass to other particles, announced in July 2012. Physicists have said they will be studying the Higgs for the next 20 years at the Large Hadron Collider in Europe, and perhaps at successor machines, hoping for a clue that would lead them beyond the Standard Model, which has ruled physics for the last half-century. Now the South Pole Telescope team has presented physicists with another clue from what a Russian cosmologist once called the poor man's particle accelerator, the universe itself. The ripples detected by the telescope, BICEP 2, were faint spiral patterns from the polarization of microwave radiation left over from the Big Bang. They are relics from when energies were 1,000,000,000,000 times greater than the Large Hadron Collider can produce. These gravitational waves are the long-sought markers for a theory called inflation, the force that put the bang in the Big Bang, an anti-gravitational swelling that began a trillionth of a trillionth of a trillionth of a second after the cosmic clock started ticking. Scientists have long incorporated inflation into their standard model of the cosmos, but as with the existence of the Higgs, proving it had long been just a pipe dream. Astronomers say they expect to be studying the gravitational waves from mountaintops, balloons, and perhaps satellites for the next 20 years, hoping to gain insight into mysteries like dark matter and dark energy, the so-called cosmic kahuna that now dangles before astronomers and physicists is understanding what caused inflation. What is this stuff that turns gravity on its head? As Alan Guth of MIT, a founder of inflation theory, has put it, and blew up the universe. Anti-gravity may sound like a crazy science fiction idea, but Einstein himself introduced the notion into physics. For him, it was a fudge factor, known as the cosmological constant, that he inserted into his equations to account for the fact that the universe didn't collapse. He later abandoned the cosmological constant, calling it a mistake, but it was resurrected 15 years ago when astronomers discovered that the expansion of the universe was speeding up because of the mysterious force called dark energy. As with inflation, the repulsion is part of space itself. The bigger the universe gets, the more powerfully it pushes apart, resulting in an exponential runaway expansion. The recently discovered Higgs field could also behave in this way. It was by playing mathematically with a version of the Higgs field in 1979 that Dr. Guth stumbled on the concept of inflation. In the years since, dozens of versions of inflation have been proposed, like chaotic inflation, eternal inflation, slow roll inflation, hybrid inflation, supersymmetric inflation, and natural inflation, based on various kinds of fluctuating hypothetical fields, assuming they are confirmed, and they have yet to be published in a peer-reviewed journal. The BICEP 2 results eliminate most of these versions, including the Higgs, according to a Stanford physicist and inflation theorist. But the winnowing could go on for decades. Knowing inflation's identity could be crucial if scientists are ever to unwind cosmic history back to the beginning, when they suspect the universe was ruled by a single unified force instead of the 4 distinct forces we know today: gravity, electromagnetism, and the strong and weak nuclear forces. The BICEP 2 waves seem to date from the time that theorists suspect electromagnetism and the weak force divorced the strong force, gravity having already gone its own way. But it's not known exactly. If the chain of evidence and reasoning holds up, however, the bicep two waves do bear witness to the most fervently hoped for unification of all, or what John A. Wheeler of Princeton once called the fiery marriage of Einstein's gravity, which shapes the universe, and quantum theory, which governs the behavior of atoms inside it. The discovery suggests that gravity, too, might ultimately be described by the same weird quantum rules as those that describe the other forces. According to inflation theory, the bicep two waves are magnified images of the hypothetical particles called gravitons that would transmit gravity in quantum theory, imprinted on the cosmos when it was a subatomic quantum speck. They have been blown up a trillion times and spread across the sky for inspection. It would take 1,000 trillion Large Hadron Colliders to make one in the lab, but the poor man's particle accelerator has done it free of charge. The universe does what we can't do, said the physicist Lawrence M. Cross of Arizona State. This telegram from the past does not give any details about what might be the right quantum gravity theory. One well-known effort, verging on old age and lacking experimental proof, is string theory. But, as they say, there is more. The gravitons themselves, theory says, are produced by the same process by which black holes leak. Now they say that gravity is indeed quantized, involving graviton particles, whatever that might mean. And this, too, is another sign of the end of times as we know them, transition days, which is a time of extraordinary changes, happenings, and events. Everything is connected, and everything is numbered. It's also about what kind of world are we leaving to the future generations, and that should be a very important question to ask. Genesis Chapter 1. In the beginning, God created the heaven and the earth. 2. And the earth was without form and void, and darkness was upon the face of the deep, and the Spirit of God moved upon the face of the waters. 3. And God said, Let there be light, and there was light. 4. And God saw the light, that it was good. And God divided the light from the darkness. 5. And God called the light day, and the darkness he called night. And the evening and the morning were the first day. 6. And God said, Let there be a firmament in the midst of the waters, and let it divide the waters from the waters. 7. And God made the firmament, and divided the waters which were under the firmament from the waters which were above the firmament. And it was so. 8. And God called the firmament heaven, and the evening and the morning were the second day. And these are more signs of the times.